Hi, let's go over the final exam question solutions. Here in the first question we have 5 values, so n equals 5. We take the average for these row. We have 5 values, take the average, and then write the range. Range is maximum minus minimum. So when we fill these columns, we will have these values in the last two columns. So in order to find the x bar, which is the average of all the averages, we add them all and divide by, how many do we have? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we divide by 20. We end up with x bar 1.627. You can take it as 1.63 or 1.6, whatever you like. But when we calculate these, so I think we need 2 decimal points after the point. So the range average is when we add all of them and divide by 20, we find the range average. So here are the formulas. Here A2 is found by looking at n equals 5. So 1.627 plus 0.577 times 0.046, which is the range average. So here some of the students took this as wrong, A2. So lower control limit is calculated by subtracting this part from 1.627. For the upper control limit range, we have these formulas, and when we look at n equals 5, D4 is 2.114, and for lower control limit, D3 is equal to 0. So these are the limits for the range, and these are the limits for the x bar, x average. So generally, we draw x bar chart above the r bar chart. So when we put the limits, label the limits, and then try to point each measurement on the control diagram, and we have this value. Again, for every point we have r value, so you can just do like this. For this value, r is like this, so we can just look at both of the diagrams at the same time. Now for B part, the process exhibits statistical control because none of the points are out of the limits. So they're all inside the limits. So we say that the process is statistically under control. The C part is 95% confidence interval. You could take this 95 as 90. It was up to you, but I took 95%. So alpha is 0.05. We have the formula from the previous chapters. Since we have 20 values, since it is not 30, we don't take z table, we don't take the z value. We look at the t table. When we have numbers, values less than 30, we take t value as the calculation. So here's the formula for the confidence interval of the average, and we find t value as 2.776. So for calculating sigma, since we didn't have any sigma or standard deviation in our calculations. We didn't calculate the standard deviation, but we calculated the range average. So from that range average, we have the formula. We can divide the range average by D2 to find the standard deviation, which is 0.02. And for this formula, we can just replace the sigma with 0.02. And from the table, as we said, we find 2.7976. When we calculated the confidence, the confidence interval on the standard deviation. This is the confidence interval for the average. When we want to calculate the confidence interval on the standard deviation, we write the variance, which is the square of standard deviation. So this is the formula. We use the chi-square table to find these values. And we take alpha is equal to 0.05. Again, n is equal to 20. No, n is equal to 5. N minus 1 is equal to 4. So when we calculate, put the values in place, we find that the variance should be between 0.001 and 0.0033. For the first question, those were the answers. For the second question, we have a table again, and in this table, number of non-conformities is given, and we would like to have again the control diagram for proportion of non-conformities. So it says set up a control chart for non-conformities using these data. You could, if you wanted to, you could take other charts, but I saw that you prefer to draw the proportion of non-conformities. How do we find it? Since for each time we have 25 plates, we need to divide 1 by 25, 1 over 25, to find the proportion of non-conformities. So here are the values that should be calculated, and when we write them, add them and divide by how many? 15. Divide by 15, we find that the average non-conformities proportion is 0.08. So here is the formula for upper control limit. P bar plus 3 times square root of P bar times 1 minus P bar over N. So when we calculate all of these, we find that upper control limit is 0.24, which most of you have found it. Lower control limit, when we calculate it, we again take P bar value minus this part. Now, the interesting thing in this solution is that we find that lower control limit is minus 0.08 when calculation. But can a proportion be negative? That's a proportion. Or we can say, can a percent be negative? No. So, since it cannot be negative, we should take lower control limit as 0. This was the part that most of you have made a mistake. So again, we draw the diagram. Some of you couldn't label this point as out of control. This was inside it. So some students lost points from that because there wasn't a point out of the limits. You couldn't say that the process is not statistically under control. So that made a lot of point loss also. So when we draw the lines and we put the points, we see that there's a point out of the limits. So what is our interpretation? The process is not statistically under control. The process should be stopped. What should be done? I asked. So the process should be stopped at that point, and the reasons should be investigated. Why did we have a point out of this limit? For calculating the CPK value, we have the formula for that. The thing is that here you wanted to put X bar in place of P bar, but in our situation we had the P bar diagram. So the average would be this. This was the average, 0.08, not 2, because we are dealing with this control diagram. So the difference between the upper control limit and the center line is 0.16. So that's 0.16. So this part is 3 sigma. 3 sigma is equal to 0.16. For this calculation, for the denominator part, you should be writing 0.16. So you know the upper specification limit given in the question, 0.16 minus, that was 0.08, all over 0.16 would give you 0.5 for both of them, actually. So 0.5. When we calculate for CPU and CPL, this is the upper control limit, lower control limit. For both of them, we find that the value is 0.0. So CPU is 0.49, CPL is equal to 0.49, and for CPK, we take the minimum of them. Both of them are same, so CPK is equal to 0.46, which is 0.5. Since ideal CPK is equal to 2, the process needs improvement. So we are really very under 2, 0.5 values. The standard deviation of the process should be decreased. So we have a high standard deviation, which is, I think we didn't calculate it. No, we calculated. It is sigma here is 0.05. This is high. We need to decrease this, like for example 0.01. If we make a calculate the value, in place of putting here 0.05, if we put 0.01, then this value will be higher. These are the interpretations of the result. So let's pass on to question 3, which is sampling plan is big N is equal to 100,000. Sample number 500. This is 500. Some students took it as 5, but it was 500 on purpose. So C is equal to 0. Draw the OC and AOQ curves. What is the average outgoing quality level? So for this question, we had N equals 500 and C equals 2. So let's write the values again. When we calculate the p-values, the formula is PA, that's the acceptance of the p-value. PA is equal to n factorial over d, the defective, how many defectives? D factorial times n minus d factorial times p over D and 1 minus P over N minus D. So in our situation, D was 0 because C was 0. If we had D is equal to 1, then we wouldn't accept it. That wouldn't be PA. So for our situation, it would be 500 factorial over 0 factorial, 500 minus 0 factorial, P over 0 and 1 minus P over 500. So these 500 factorials cancel each other. This is 1, again this cancels, so we are left with 1 minus P. So when we decide on the P value, then we would subtract that P value from 1 and take the 500 times we calculated, multiply it, and it would be the PA value 0.95. Now this is very important because in the exam I think almost, not two students, but almost everybody except 2 students had P values like 0.05, 0.01, 0.02. So these were the values we had in the class, but when you calculate the PA value, the acceptance of this proportion quantity, the PA values are low. For example, let's draw the OC curve. Now in this OC curve, the important part of OC curve is PA starts from 0 and ends at 1. So the values should be between 0 and 1, and we should find the P value that would give almost the probability of accepting that lot is equal to 1. So in the exam, most of the students were here. So you were giving this part in the exam, but we needed to find the alpha equals 5 value, which was 0.95. So this point was important for us. Why? Because it would give average outgoing quality, average quality level, this part. So okay, you just label this alpha and say that it's the sailor's risk, but the values were between here, and there wasn't a value at 0.95. That was the very big mistake. Actually, the P values should be considered very, very small. So you should start with 0.0001. You should try 1 or 2 times what would be the PA value. So when you reach the PA value as 0.95, then you're on the right track. You don't have to take these much numbers. You could take, for example, 5 or 6 values, but this part is important. You should take a P value that would give at least 0.95 acceptance probability. So for the other graph, which is average outgoing quality curve, we need to multiply P with the PA value, and there should be a graph like this going up and down, and there was a limit for that part. and that limit here is 0.000074. So that's the average outgoing quality level. Here are the graphs, curves for two of them. This is the OC curve, and when we take very small p-values, we could reach 0.95 value. So this is 0.0001 is the average quality level. And since we start from there, we can go like this. And for the average outgoing quality curve, we pointed the values here and draw the curve, and that limit is, as we found previously, is 7.4 times 10 over minus 4. So for the fourth question, you should write what you have learned in this course. And the fifth question was reading, this part was reading the tables. How to read the tables. That was important. I will show how to read the tables in the next video. I will bring the tables here.